Okay, so I have a plot of a velocity of a particle. It gives me the acceleration as a function of time, and I want to find. It has an initial velocity of 12 meters per second, and basically, I want to figure out, hey, what is the velocity? What is the position? Okay, so what I'm going to ultimately do here, and we'll start with my velocity plot, which will be like this. Okay, as a function of time. And this is going to start at 12 meters per second, like so. Okay, so what I need to do here is I need to first tell you what this equation of this line is. And this is essentially a linear line going downward, so it's a negative slope. And the rise over run is, well, -3 rise and a 4 run. So the equation for this would be -3/4 t. Okay, and similarly, then that flat portion of the is just a constant. The acceleration is just -3. Okay, so what I'm going to do here is use my acceleration equals dv dt equation. Okay, and I'm going to use separation of variables and basically figure out that dv equals, oops, not a, equals a dt. Okay, so I'm going to basically integrate my acceleration equation to get to my velocity equation. So I'm going to integrate from 12 up to some unknown velocity, dv, and then I'm going to integrate from um, my time, which will be from 0 to t, of the acceleration, which will be -3/4 t dt, like so. Okay. Um, from this, I get the integral of dv is just v, so that's going to be v minus 12. Okay. And then my integral of there will become -3/8 t squared, like so. Okay. Solving this for v, my v equation then becomes -3/8 t squared plus 12. So when t equals 0, v equals 12. And when t equals 4, my v actually equals 6, plugging that in right there. So my equation is squared. It'll look something like that, okay? Following a quadratic path down to 6, like so. Okay, now to go a step to do the next one. Okay, I'm going to take, now I'm going from 6 to v dv, and from time I'm going from 4 to t, and again my acceleration here is simply -3 dt, like so. So this one becomes very simply v minus 6 on the left side. And then what I get here is -3t. Okay, but again, I'm going from t to 4. So when I plug in 4, I get a plus 12. Okay, and from that, I get my velocity equals -3t plus 18. So when t equals 4, my value becomes 6. When t equals 9, my value becomes -9. And it's just a straight line on this one. So that'll look something like this. Okay. For what it's worth, this guy crosses over when t equals 6. That's when the velocity equals 0. Okay. What that's going to tell me is basically when the position changes direction, where I have a maximum on my position, which will be my next thing. So that's an important thing to recognize. So that's what v looks like as I move through. I integrate one more time to go to s, right? Because again, just the fact that v equals ds dt. So again, I'm going to integrate ds this time, and I'm going to integrate v dt, where v initially is negative 3/8 t squared plus 12, like so. And then that'll be dt out in front of that, okay? So this side I go from 0 up to s, and this side I go 0 up to, again, some arbitrary t, like so. So then that becomes, the left side just very simply becomes s, and the right side becomes negative 1/8 t cubed plus 12t. Okay, and again, when it starts at 0, everything just drops away. So then that's what s is. Okay, so when t equals 0, s equals 0, this thing starts at 0. And when t equals 4, I plugging that in, I actually get 40. Okay, and this is a cubic. You can plug it into your calculator to figure out what that looks like. That's more of a straight line. I'm not sure how this looks. Okay, we'll just say it looks something like that. But again, it's going to start at 0, go up to 40. It's not going to cross 0 any place. It's not going to have a peak or anything. So it'll just look something along those lines, like so. Okay, going to the next one. Okay, integrate ds, but now this time I start at 40 and I go up to s. Right, and I start at 4 and go to t, and I use, again, now my second equation, which is the negative 3t plus 18. Okay, so from this, I get s minus 40 for the left side. Again, integral of ds is just s. Again, s minus 40. And then the right side becomes negative 3/2 t squared plus 18 t minus 48. Okay, and I'll let you figure that all out on your own. You can follow along. But then solving this for s, I get negative 3/2 t squared, okay, plus 18t minus 8. Double checking, when I plug in t equals 4, I get 40 for s. Okay, when I plug in t equals 9, I get 32.5. Okay, and the other one of interest will be t equals 6, and when t equals 6, right, that's where this thing peaks out. This becomes 46. So I get an equation that looks something like that. Okay, so with these graphical things, you just basically either integrate or differentiate depending on which way you're going, whether it's from, acceleration to velocity or from position to velocity, that sort of thing. Just find the equations, differentiate, integrate, draw your equations out. Note where things cross 0, because you may have local maximum and minima and things of that nature. So hopefully this is something that you've looked at when you took calculus. If not, here's how you go relating between acceleration, velocity, and position as a function of time, and you can do it graphically.